Hello and welcome to Instructor Allison online tutorial. So for this particular video, I want to tell you about the oxidation number of a particular, now two rules now I want to join together because now the last rule I want to give you, I'm supposed to do rule 7 and rule 8, but I want to join all of them together. So this will be the last video on the rules in this oxidation number. So this subsequent video will be solving problems upon problems upon problems. So this particular rule is talking about the algebraic sum of all elements in a compound. Note that it is 0. I'll give you two conditions. The first one is that the algebraic sum of all elements making up, let me just start with the first one. The algebraic sum of all elements in a compound is equals 0. So you need to be familiar with this. For example, if I have this particular compound H₂SO₄, the algebraic sum of all these things, the algebraic sum, that means adding hydrogen plus this sulfur plus oxygen, even though I multiply them by their subscript as the case may be, the summation of everything will give us 0 as long as it doesn't have any charge on the radical. As long as it doesn't have any charge on the radical, the sum of everything here will give us 0 when you want to do calculations. So maybe you are asked to calculate the oxidation number of sulfur in this particular compound. By the time you're working on this thing, you equate everything to 0. That's the meaning of this thing when they talk say the algebraic sum of all elements in a compound now equal to 0. Now be the first one. No? What of the second one? I say I go do 2 in 1. The second one we say the algebraic sum of all elements, the algebraic sum of all elements making up, let me take it up a little, making up a radical. I've already explained what radical is on the other videos. You could just head over to my YouTube channel and search for that on this oxidation number. Is the charge of the radical. Don't worry, I'm going to explain this particular one in 1 second. Of the radical. Okay, so what this means is that, say for example, if I have something like say CO3 and maybe 2 minus. Sorry, there's no one there. Let me do that nicely. Good. Okay, so this is carbonated radical actually. So now you can see that the algebraic sum of all elements, when I say all elements, I'm having carbon here, I'm having oxygen. How many of them? We have about 3 of this oxygen. All these elements put together plus this charge on it. All these elements put together gives us this CO3, then the charge on it. So this is where I was saying that the algebraic sum of all elements making up a radical is the charge of the radical. So the charge that is there, which is this one, becomes the answer. So you're going to equate the whole of this by -2. That's what it means. So with this particular one, you can be able to solve a lot of problems. Say for instance, if you're asked to find the oxidation number of sulfur in this SO4, this sulfate radical like this, it means that if I'm looking for the oxidation number of sulfur will then become X, which is the element I'm looking for, plus, remember I told you the oxidation number of oxygen in most states is -2. So -2 we multiply by this subscript, which is 4, Then you equate everything. This way I would say you equate everything by the charge. That's why I say the algebraic sum of all elements making up the radical is the charge of that radical. So is equal to the charge of that radical. You can see that algebraic sum, meaning I'm adding up these things. So x now plus, by time you multiply 2 and minus 2 and 4, that gives you minus 8. And plus minus will give us minus. So yes, supposed to be minus. Okay, let's just put it as minus 8 like this, equal to negative 2. So now plus minus is minus. So if this 8 moves over to the other way, or add 8 to both sides of the equation, you have minus 2 plus 8, and that will give you about 6. I hope this is pretty simple. So thank you so much for enjoying this particular video. I'm going to be doing another one. I'm going to do plenty of this particular one, solving exercise by exercise, to make sure say everything clear for your eye. I hope you enjoyed this particular video. Thank you so much for watching. Subscribe to this YouTube channel, share this video, and make sure you hit the like button, and then comment whatever it is you want us to fix in the next question. Thank you.